So one of the questions that some of you might be wondering is like, why using a robot simulator? What's the kind of point of this software? So this image here is actually from the Webbots website, and it more or less like highlights like the process and why this kind of software is very useful. So first of all is that using a robot simulator like Webbots, you can model like a particular robot. You can design your own robots, or you can get one robot that already exists in the market, like an industrial robot, like for example a universal robot like the ones we saw on one of the previous demos. And you can make, small changes. You can change the gripper, add new sensors. So it makes it very easy to model your own robot, as opposed to being in the actual factory and changing the pieces, which might take like a few hours, and here it's just a few clicks. The second thing is that once that you have modeled your robot and you have like a digital robot on your system, you can program its behavior. So you can, with a programming language, define how is it going to work. So for example, in the previous example, the one with the factory and the cans, you can program something like, the robot is going to be waiting for a can, and when a can it's on the robot gripper, the gripper is going to close, and the can is going to be moved into a box. Or any kind of behavior, like for example the one with the drone flying up and down, or the humanoids, anything that you can define with code, you can program the robot to do. And then the most important step is actually to simulate the robot. So you can see in this image something which is quite interesting, is that you can see two small robots here, and then you can see one environment with walls, boxes, and things like that. So the main idea of a robot simulator is to actually simulate how the robot works in an environment in order to optimize its behavior. So for example, you were having like a universal robot with a particular gripper, and you test to see how well it can grip the different cans, and you simulate it and you obtain some results, and then you actually decide to change the gripper and choose another one and simulate it. So it makes very easy to test different possibilities, try to optimize the environment, try to see what works best. And finally, probably the last step, which is probably the most important one, is that once you have model, program, and simulate your robot, you can actually send it to an actual robot. Here you were modeling in the step one, you were modeling your universal robot. On step two, you were programming it. On step three, you were simulating it. But now that you have found like the perfect combinations of characteristics and programming, you can actually send this information to the actual robot arm. And obviously, this is probably like, I don't know, I mean, all the steps are very important, but this is maybe like the most important one, because otherwise, if you cannot transfer this information from the simulated world into the real robot, then a bit is like, what's the point? So this is actually extremely important, and Webbots enables you to do this through Wi-Fi, Bluetooth, and different types of connections. And I guess just going through this list, like some of the main reasons is that obviously while you are testing the robot and everything, you are saving a lot of materials and equipment. You don't need to go to the factory with your car or train and everything. All the work is remote, either from home or from the office. It's very easy to deploy to robotic cells. So perhaps you remember from last week that the last lecture that we were speaking about a robotic cell, which is like a kind of container that has a robot, tools, and equipment and everything in an encapsulated environment that you can replicate many times, and you can connect between them. It's like sending like a solution for a particular task. So you can simulate it in your software, and then you can transfer this simulation to like dozens or hundreds of different robotic cells which are connected and working all around the world. Obviously, because it has all these advantages, one of the main things is that you can test the configurations very fast. And as I will show later on, one of the main characteristics of this is that you can get the simulation to work very fast, like really, really way faster than real time. So perhaps a task that in the real world is going to take like 10 minutes, in a simulator it can take like seconds, and you can see if the results are good or not. You can optimize the systems to, for example, like minimize the energy, minimize the costs, how many robots you need. People in general wants to buy, the number of robots as little as possible because they are expensive. So you can simulate the same environment with like 2-3 robots, what are the pros, cons, what works better. And then also for the students, the last one is like it's easier to learn, how to work with robots when you are not breaking something that is half familiar. With a simulator, you can just try crazy stuff and see if it sticks or not. When you're working with a real robot, you need to be, very careful about what you do because you don't want to break it. I wanted to discuss very briefly something because in the previous slide I was discussing about how a robot can be used to simulate the environment, optimize, decrease costs, and all these kind of things, which is true. But we also need to be careful. We need to start being careful about considering that everything in software is free, because it's not. I'm sure all of you know probably better than me, like it's been on the news lately, like the crazy energy consumption of Bitcoins, which is more or less the same as a country of Netherlands. So it's like a very big amount of energy. But then if you consider like the whole data centers worldwide, it's sort of like doubles the consumption of Bitcoins. And these data centers, are like Google, Facebook, Netflix, all these kind of different services. So, we need to be very careful about how much energy we're actually using in software because it's not free. And I found the other day like this news on the internet. And it says that by 2040, IT technology is going to account for a 14%, so this is actually a lot, of 14% of the world's carbon footprint, up to a 1.5 in 2007. So you can see that computers in 2040 are going to use like a 14%, which is a lot. And then something quite interesting here, and this is that training a single neural network model today can emit as much carbon as 5 cars in their lifetimes. I guess this is one of the very big networks that Google, Facebook use, and the amount of power it requires doubles every 3.4 months. So imagine that you're using like a neural network to optimize your robotic setup to some particular action. If the computation of this simulation is going to be something like 5, like the same consumption as 5 cars, then probably you need to think if it's worth it, basically. Like, is it worth it? And the energy I'm saving with the simulation is not going to be offset with the energy I used to do the simulation. And yeah, software sustainability is a big thing now, because for a very long time it was considered that software was free and cheap. But it's not. There are already like some kind of like institutes in the UK, and there are like different engineering practices about how you can get together human resources, energy resources, economic resources in order to decrease the sustainability. So this was more or less an introduction of robots, like why we need a robot simulator, and also to consider that not everything is amazing and there are some downsides, in particular like the kind of energy, the quantity of energy they can consume.